Now we will learn about some of the trigonometric identities. Let me just first state the trigonometric identities and then I'll proceed to explain how and where they come from. Okay. The first and foremost is sine square A plus cos square A. This is equals to 1. Next comes sec square A is equals to 1 plus tan square A, and the last is cosec square A 1 plus cot square A. Now to understand this, let us consider a right angle triangle ABC, right angle at B. A, B, C. Okay. So we know that sine A, suppose sine A is BC by AC. So sine square is BC square divided by AC square, and cos A is AB by AC. So this is AB square divided by AC square. Now from the Pythagoras theorem, we know that BC square plus AB square, this will be equal to AC square, because base square plus altitude square equals to hypotenuse square. So BC square plus AB square, this is equals to C square divided by AC square, this is equals to 1. So we see sine square A plus cos square A, sine square A, cos square A. When you add these two, sine square and cos square of the same angle, you always get 1 irrespective of the angle. Now let us divide both sides of the equation. This equation, let us divide the whole equation, both sides, by cos square A. So we get sine square A by cos square A. Sine by cos is tan and it is squared, so we get tan square A plus cos square divided by cos square A is 1, and 1 by cos square A. 1 by cos A is sec A, and sec A square is sec square A, which gives us the second identity. Okay. Similarly, if we divide this whole equation by sine square A, we get 1 plus cot square A equals to cosec square A. This is the third identity. These identities come from basic Pythagoras theorem, but they really help us to solve some tricky questions and generally make our life easy in understanding trigonometry. Let's try some examples to understand this better. I will just let these identities stay right here so that you have no trouble referring to them at any point. Okay. Let's say first, let's say we are given the value of sine A and only sine A, nothing else, and we have to find everything else. So just as an exercise, let's do that. We have to write every other trigonometric ratio in terms of this sine A. Okay. Now how do we proceed? We use the first equation for the first cos A. So we know that sine square A plus cos square A equals to 1 implies cos square A equals to 1 minus sine square A implies cos A equals to plus minus root over 1 minus sine square A. This plus or minus sign depends on the angle, but since we are talking about right angle acute triangles, we assume that A is always going to be above 0 and below 90. So we eliminate the negative sign, we are going to take the positive. We get cos A equals to root over 1 minus sine square A. Okay. Now sec A is 1 by cos A, so we get sec A equals to 1 by root over 1 minus sine square A. Now cosec A is of course 1 by sine A. We are left with tan and cot. What do we know tan as? Tan A, in terms of sine and cos, we know it is sine A divided by cos A. Now we have already found out the value of cos in terms of sine, so we substitute here. We get sine A divided by root over of 1 minus sine square A. Cot A is just the reciprocal of tan A, so we get root over of 1 minus sine square A divided by sine A. Alright? We can do this for any of the 6 ratios and find what we want for all the ratios. Okay, let's do some other examples. Suppose we are given this, we have to prove, okay, prove that sec A into 1 minus sine A into sec A plus tan A, this is equals to 1. These kind of questions can be proved, or they can just directly ask you the value, anything. You just have to be prepared. So first we write this in terms of the numerator and denominator. We see this is 1 by cos A into 1 minus sine A into 1 by cos A plus sine A by cos A. We take cos A common and this becomes 1 plus sine A. So we got in the numerator 1 minus sine A, 1 plus sine A, and in the denominator we got here cos A into cos A. This gives us 1 minus sine square A. I hope you are familiar with the property. 1 minus A into 1 plus A is 1 minus A square, or A minus B into A plus B is A square minus B square. In this case A is 1, so we get 1 minus sine square, and in the denominator it is cos square A. Now since we know sine square A plus cos square A is 1, so similarly 1 minus sine square A is equal to cos square A. So we get cos square A divided by cos square A. This gives us 1. Okay. We have got a few more examples. Now, suppose we have to again prove LHS equals to RHS. LHS is left hand side, RHS is right hand side. LHS we are given cot A minus cos A divided by cot A plus cos A. This gives us, we have to prove that it equals cosec A minus 1 divided by cosec A plus 1. Now we start of course from the LHS and we proceed to RHS. Now what do we know cot A as? Cot A we know as cos by sine. Okay, so we take cos common, like cos A by sine A minus cos A divided by cos A divided by sine A plus cos A. This is equals to, we take cos A common from the numerator as well as the denominator. So we get cos A 1 by sine A minus 1 divided by cos A 1 by sine A plus 1. Alright. We cancel out the cos because of course it isn't 0. This is another thing to remember. When you are cancelling out from both numerator and denominator, you have to make sure that they cannot be 0. Okay. Now we are left with this. 1 by sine is obviously, as we know, cosec. So we get cosec A minus 1 divided by cosec A plus 1. See, the interesting thing is, we did it this way, but we could also have used identities. How? We could have multiplied this by cot plus cos divided by cot plus cos, and we would have still seen the same result. Okay, you can try it by different methods if you feel like it. It will help you get a better understanding, a better grasp of the concepts. I would suggest that you do more problems of the sort so that you can easily remember these identities and solve questions, the more tricky questions. Now let's say this is a question type you will encounter a lot, I think. We have to again prove that sin A minus cos A plus 1 divided by sin A plus cos A minus 1, this is equals to 1 by sec A minus tan A. The additional condition given here is that we have to use the identity, the second identity that is this one, sec square A equals to 1 plus tan square A. Now we see that in the LHS we do not have a sec or a tan term. How do we bring it? We divide both numerator and denominator by cos A, then we get sin A by cos A, that becomes tan A, cos A by cos A becomes 1, and 1 by cos A becomes sec A. So we start with this. The LHS becomes tan A minus 1 plus sec A divided by tan A plus 1 minus sec A. We multiply both numerator and denominator by tan A minus sec A. We are doing this because we have to use the identity, and to use the identity we have to get square terms. The best way to get square terms is to find out something that will act as a square minus b square and multiply accordingly. Tan A minus sec A. This will give us, once we multiply, sec plus tan into tan plus sec into tan minus sec, which is a square minus b square, again gives us tan square minus sec square A, and minus 1 gives us minus tan A plus sec A. We divide the denominator, we get tan minus sec whole square is tan square minus sec square plus 2 tan sec, and so tan minus sec whole square, this is tan square plus sec square minus 2 tan A sec A, and then plus 1 plus tan A minus sec A, tan A minus sec A. Alright, now we know that sec square is equal to 1 plus tan square minus sec square is minus 1. Okay, and sec square is 1 plus tan square, so we proceed accordingly. I think I seem to have made a mistake. We should probably take tan plus. Yeah, tan plus would be better, I think. Let's redo this. Okay, so we see sec plus tan whole square, sec plus tan into sec plus tan minus 1. So we multiply sec plus tan into sec plus tan minus 1 into sec plus tan. So we get sec plus tan whole square, which is sec square plus tan square plus 2 tan sec minus tan minus sec. Now we know that sec square is 1 plus, let's just write this down, sec square a plus tan square a plus 2 tan a sec a, and we get here minus tan a minus sec a divided by, we get tan minus sec into tan plus sec. This gives us tan square minus sec square, tan square a minus sec square a, alright, and plus 1, this gives us plus tan a plus sec a. Okay, now we know again that tan square minus sec square is minus 1, so we do that, and tan square is sec square a minus 1, so we get minus 1 plus tan a plus sec a, and in the numerator we get 1 plus 2 tan square a plus 2 tan sec minus tan a minus sec a. Okay, now we solve for this. We get this as sin square a by cos square a into sin by cos square a. If we continue like this, we will get the answer. Okay, I think that does it for the examples. We will move on to something, the application of trigonometry, where trigonometry is actually applied in the real world. It's called heights and distances, and I think it will be very interesting to follow. All right.